Hey everyone, I have two things that I wanted to say. First, I have a video coming out pretty soon. It is on basically making things autonomous using AI. I think I've probably went over this already with you guys. I'm pretty sure I have. But I have the full-blown video coming out soon. There's been so much happening in the background. I'm a little bit behind on the things that I need to deliver. The second thing I wanted to call out was in the Discord, Yuval, I'm not entirely sure if I'm pronouncing that correctly. You posted two automations. I've looked at one of them, but this is what you posted. Yeah, you posted this one and another one underneath. You're very interested in having, I guess, different automations and trying to optimize things that you have. I was hoping for others to also kind of pitch in the sense of like if they had ideas or different ways that they would have approached this. Not to say that you guys have to, but I'm always curious as to like how others would approach these type of problems. My understanding of the automation is that, actually let me point at it. It seems to be automation where you check for the AC if it turns on, that you would basically turn it off if it detects any doors or windows that are open. There are parts of this that are disconnected, so I'm not entirely sure what those are supposed for, but in general it seems like if the AC is on, then you're basically checking to see if doors or windows are open. If there are, you would send a message to both your home assistant, like the speakers in the house, as well as to Telegram. And then as I guess doors or windows are being closed or changed, it seems like you either send a message when it's like if everything is okay, and if everything is not okay and things are still open, then you basically, here it is, announce what's wrong as well as turn off the thermostat. I suspect that there's other nuances to this, at least I couldn't readily understand it, but if that was the basic gist, then I have two automation suggestions. This revised automation cuts this down by over half, but again, I suspect I may be missing some nuances from your previous one, so it may need some more nodes depending on your use case. The important thing is to check to see if the AC is turned on. What reduces this down drastically is this section here. We're basically checking the doors and windows. I am just pointing at something obviously wrong. I don't have your same entity, so I just put in like mock entities for myself. But essentially, like, you look at the particular Home Assistant will tell you whether or not something, like if the group is open, so you have all of your doors and windows under a single group. And then if it is, you're basically gonna have it, the part I wanna show you is that it's returned, it's outputted as an array right there. So it comes back as an array and it gets sent into the payload. And because it's an array, it's either filled with something or it's empty. I have this function node here that will basically loop through that array. So if message.payload.length, if it's greater than 0, meaning that there is something that is on, then we can basically cycle through it and I can get all of the names, and then I can create the various messages that we need. So, you know, you have 90 seconds to close the windows and it just lists out all of the items. There goes a failure message and there's a success message up top. And what the function node also allows you to do is to basically dynamically change what endpoint or output you can send things through. So right now you see that it says return null messages, meaning that it's sent to the second output. So if there are messages, it's going to go to the second output. Otherwise, if it's empty, meaning that there's nothing open, it's going to go to the first output. And you can see that there. So if it was empty, if after checking the doors and windows that there was no items, it's simply just going to make that announcement and then we stop at the end. However, if it wasn't empty and there are items in there, then we're gonna send message to Telegram as well. And I see we're gonna make that announcement, and then we're gonna have this wait until. You had a lot of triggers and I wasn't entirely sure what you were getting at with the triggers. But I just had this simple wait because, again, since it's triggered by simply the AC being on, we at this point only care if the doors and windows are closed or if they're still open. So we're gonna wait for some kind of amount of time, in this case 90 seconds, and we're waiting for the state of whatever your group entity is to be off, meaning that all the doors and windows are closed. If it is closed within that time frame, then we simply go back and do the success message, meaning that, you know, everything is closed and everything is fine. However, if within that 90-second period it times out, then we basically send another message and then we turn off the thermostat. There is a use case of if, let's say, the AC is on and everything is fine, and then at some point someone opens a window, then we would have to go through a flow similar to this again. But I don't think that that was caught here. At least it doesn't seem like your original one kind of took that into consideration. So I wasn't really stressing that. As a result, I wasn't sure what this node was supposed to do either. I feel like this one should have been good enough, but just to keep parity with what you had, I just left that there too as well. But essentially this kind of minimized and simplified the flow. And this is a hard-coded version where we can kind of step through step by step. I do have a version that uses AI. This AI version is rather interesting. Essentially, we have this system node here that tells it what it's in charge of. So basically it's in charge of the thermostat, and the instructions are fairly straightforward, right? We tell it that if the air conditioner is on and any doors or windows are open, then it needs to turn it off. And then if the air conditioner is off, then we can just leave it off. I told it to just respond back with a short reason why it shows which of the functions. And then if it needs to turn off the AC, make sure that it lists the doors and windows that are open in its explanation. Because of all of this, what this does is we're offloading all of the business logic that we did here in like these, that we did in these nodes. So like this function node, which had all of this business logic, like we're basically offloading that to the AI and let the AI determine what to do and all of that jazz. We pass this when the automation starts. It starts the same way as all of the other ones start. When the AC turns on or it's in some kind of on mode, the first thing it's going to do is it's going to grab the status of the house. That's what the AI is going to need. So we give it the status of the AC, whether it's cool, heated, whatever the case is. And then I have here a binary sensor group of all of my Ring contact sensors for all of the doors and windows. So I created that here, and we're simply just doing a loop and printing all of that out. So it knows that for the front door, it's open versus closed. For the back door, open versus closed, windows, etc. All of that is going to get sent here to this user node. You see here, here's the current status of everything in that payload. That payload is coming from here. And then of course I already showed you what was in the system node, which gave it all the instructions of what to do. And then it just passes it to AI. The AI is going to send it to basically print out a response. And what this is going to do, I probably should show this one more time. I didn't mention this. In the instructions, it also mentions like, hey, you have these two type of things that you can do. You can call turn off AC or leave alone. And here it leaves the air condition to whatever state it's in, or we can just turn off the air condition. It knows when it needs to turn off the air condition based off of our states or based off of our instructions. And then in other cases, it knows that it can just otherwise leave the air condition alone. Those two functions that I've described here in the system, I've also printed out here. So this is the register intent nodes. We have leave alone and turn off AC. If the AC is on, for instance, and then it finds that one of the doors or windows are open, it will call turn off AC. It will basically make an announcement similar to what the previous ones will do, where it tells us like, hey, you know, you have something open. But instead of me generating the message here, as I've done manually in this function node, the AI will generate its own message, and it will also add in the list of items that are open. And it's going to send that to whatever speaker. You can send it to Telegram if you want. It's going to also wait for 90 seconds. During this 90-second wait, if let's say if we close all the windows in time, this door window status is going to change and it's going to turn to off, meaning that everything is closed. It's going to run this function again, and the new status is going to say that, hey, all of the doors and windows are closed and the AC is currently on. Then of course it's going to run leave alone. If it's going to run leave alone, then it's going to come here. It's going to basically give it its own announcements. Like this is going to be generated by the LLM. And this function here, basically it's going to kill the timer, and the timer will never run, so that AC will never turn off. if we don't close anything in time, then this is going to fire off after 90 seconds and then turn off the AC. And you could have a message afterwards if you want, but this is now completely controlled by AI, if you will. If that sounds interesting to you, pretty cool. It was interesting to me, very fun particular problem to solve. Whether or not it works or fits your use case, I'm not entirely sure. I just went off of what I could understand from the nodes that you've presented. The concept that you saw with the whole using LLMs to run the business logic is something that I've been experimenting with, and I'm gonna have inside the course that I'm trying to push out. You're also going to see the same concept in the video that I'm going to push out later on this week. I am just exploring what it means to let LLMs control things. Whether or not it's more efficient than what we normally do, that's yet to be seen. For instance, right, with your original automation, you had about 24 nodes. With the second automation that I showed you that was optimized had about 14 nodes. No, sorry, 12 nodes. But the new automation with the LLMs has about 14 nodes, I think, like maybe 2 or 3 more than the previous one. So whether or not we say it's better, that can really change. But what I can say is that, at least from a maintenance point of view, like, I don't have to really watch any functions or change code. I can just simply tell the LLM, hey, this is your new instructions, and then it will just carry that out. So maintenance wise, like, there's a trade-off, and that's what you see in tech all the time. There's always a trade-off between ease of use versus maintainability versus function and power. Like, there's always trade-offs. So this is just something that I'm exploring. This video is long enough. I will post the automation stuff, the what do you call it, the JSON for it, later on. I am on a different computer that doesn't have what I need, so I'll probably post it sometime this week. But just wanted to post this to you guys, so yuval, I hope I'm saying that correct, you can see and kind of try it out for yourself if you're eager. And then for everyone else, I think this is probably just a cool thing to know and to kind of play around with. But yeah, later on this week, I'll add the code so you guys can have access to it. All right, good night.